Hello! Today we are diving into the world of AP statistics by exploring the foundational concepts of probability. By the end of this lesson, you will be able to calculate probabilities for specific events and determine the likelihood of their complements. In statistics, we think of probability as the long-run relative frequency of an outcome. If we repeat a process many times, what proportion of the time does a specific result occur? To calculate probabilities, we first need to understand the sample space. The sample space, often denoted by the letter S, is the set of all possible outcomes for a random process. It is vital that these outcomes are non-overlapping, meaning only one can happen at a time. For example, if you flip a coin, the sample space is simply heads and tails. If you roll a fair six-sided die, the sample space contains the numbers 1 through 6. One of the most important rules in probability is that the sum of the probabilities of all possible outcomes in the sample space must equal exactly 1. This represents a 100% certainty that something within that space will occur. Now, how do we actually calculate the probability of a specific event occurring? When all outcomes in a sample space are equally likely, meaning no one result is more common than another, we use a specific formula for theoretical probability. We write the probability of event E as P of E. It is equal to the number of successful outcomes divided by the total number of possible outcomes. Let's try an example. Suppose we want to find the probability of rolling an even number on a standard six-sided die. Our sample space has 6 total outcomes. The outcomes that satisfy our event, rolling an even number, are 2, 4, and 6. That's 3 outcomes. So, the probability is 3 over 6, which simplifies to 0.5. or 50%. Now let's look at the limits of these values. Remember, any probability you calculate must be between 0 and 1 inclusive. A probability of 0 means the event is impossible, while a probability of 1 means it is certain to happen. Next, let's talk about what happens when an event does not occur. This is known as the complement. The complement of an event E consists of all the outcomes in the sample space that are not in E. In your textbook, you might see it written as E prime, E bar, or E superscript C. Think of the complement simply as the probability of not E. Since the total probability of the sample space is 1, the probability of the complement is very easy to find. The probability of the complement of E is equal to 1 minus the probability of E. Imagine a weather forecast says there is a 30% chance of rain today. We can define event E as it rains. If P of E is 0.30, then the probability of the complement, that it does not rain, is 1 minus 0.30, which is 0.70, or 70%. By using this subtraction rule, you can quickly find the likelihood of an event failing to happen, provided you know the likelihood of it happening. Let's apply everything we have learned to a slightly more complex example using a standard deck of 52 playing cards. In a standard deck, there are 52 cards. Each card is a unique outcome, and if we shuffle well, each outcome is equally likely. First, let's find the probability of picking a heart. Since there are 13 hearts in a deck of 52, the probability P of heart is 13 divided by 52. This simplifies to 1/4, or 0.25. Now, what is the probability of the complement? That is, the probability that the card we pick is not a heart. Using our complement rule, we take 1 and subtract the probability of picking a heart. 1 minus 0.25 gives us 0.75. There is a 75% chance of picking a card that is not a heart. To summarize, the sample space covers everything and sums to 1. For equally likely outcomes, probability is a simple ratio of part to whole. And finally, the complement rule is a powerful shortcut for finding the probability of not something happening. You are now ready to tackle basic probability problems in AP statistics. Great job today!